Okay, so in this video we want to introduce the graphs of circles and semicircles. Now a circle is a slightly different beast to what we've looked at with our other graphs in this topic because a circle is not a function. So remember, going back to the very first video in this topic, a function is something where no 2 points on the graph have the same x-coordinate, and we have a vertical line test to test for that. These 2 points would have the same x-coordinate, and obviously there's many other examples of that, and so therefore this isn't a function. And that means it behaves a little differently, or it looks a little different to our other graphs in terms of how we interpret the transformations, and that's because it's basically rearranged in a different way. And we'll have a look at exploring that today. Okay, so the most basic circle is this one here. We call it the unit circle, and we've met the unit circle back in our trigonometry topic. So the unit circle is a circle with its centre at the origin and a radius of 1. And I'm going to tell you that the equation of this unit circle is x squared plus y squared equals 1. So you'll see it's quite different in that it's not y equals something. Okay, we'll have a look at what happens when we rearrange to y equals. So x squared plus y squared equals 1 is a unit circle, a circle with its centre at the origin and a radius of 1. So the domain of x squared plus y squared equals 1, so the set of x values for which this graph exists. So we can see the graph actually only exists between -1 and 1 inclusive, okay? And so therefore the domain would be -1 is less than or equal to x, which is less than or equal to 1. In terms of the range, the y values for which the graph exists for, again we can see it is restricted. Again, it only exists from -1 to 1 as well. So the range is y is bigger than or equal to -1, which is less than or equal to +1. Okay, so we've got quite a limited domain and range when we're dealing with the circle. Okay, let's have a look at, as I said, this way we give the equation of the circle, x squared plus y squared equals 1, is a bit different to our other functions where we normally have y equals something. So if we rearrange to make y the subject, so I've started with x squared plus y squared equals 1, I've subtracted x squared, and then I've taken the square root, remembering that when I take a square root, I could get the positive square root or the negative square root. And actually what that means is we now have two different things that are both functions. Y equals the positive square root of 1 minus x squared is actually the top half of the circle. So it's a semicircle. Okay? Y equals negative square root of 1 minus x squared. I mean, if you think about how to get from there to there, you've multiplied by -1, and so therefore you've reflected in the x-axis. And so therefore this is also a semicircle, but this semicircle. So essentially our equation for the circle is made up of two semicircles, and when we manipulate it back to this form we get this much neater way of writing that equation without needing the positive and negative square root. X squared plus y squared equals 1. Okay, so y equals the positive square root of 1 minus x squared is the top half of the circle. Y equals the negative square root of 1 minus x squared is the bottom half of the circle. Now interestingly, we could also choose to rearrange the equation of the circle to make x the subject. So subtracting y squared from both sides and then taking the square root, getting the positive and negative square root. And if we think about those two separate things, x equals the positive square root of 1 minus y squared versus x equals the negative square root of 1 minus y squared. Okay, so actually x equals the positive square root, positive x. It's also a semicircle, but it's this semicircle. Okay, and similarly when x values are negative, it's the circle where the x values are negative. It is the left hand side of the circle. Okay, so if you think about that, this is where the y values are positive, top half of the circle, where the y values are negative, bottom half of the circle, where the x values are positive, right hand side of the circle, where the x values are negative, left hand side of the circle. So we've got 4 different semicircles that we can obtain by manipulating the original equation of the circle. Okay, so then let's go back to our most basic circle and think about, okay, so this is a circle with its centre at the origin and its radius of 1. Those are the two things that define the circle. If you change the centre, you move it. If you change the radius, you make it a bigger circle. Okay, so those are the two things we want to be able to control. So let's think about what transformations would be needed, or transformation, to change the radius of the circle. Now obviously it's going to be about dilation. So if we were to dilate from the x-axis, we would stretch, but our graph wouldn't stay as a circle, okay? So we would also then need to dilate from the y-axis as well to keep the circle. So we're going to need dilation from both the x and y axes by the same factor, same dilation factor. Okay, so that's going to be important too, because if you dilate this by if you dilate this by 3 this way and only by 2 this way, you don't get a circle. So you've got to dilate by the same factor in both directions to still have a circle. So we would need 2 dilations in order to change the radius, dilation from the x-axis and dilation from the y-axis. In terms of what transformations we would need to change the location of the centre, well, that's simply going to be about translation. Okay, if I want to move the centre to 2, 1, I'm going to translate to the right by 2 and up by 1. Okay, so we would need translations. Left or right or up or down, or combinations of those. So maybe we should write that as left or right and or up or down. Okay, so when we've considered transformations, we've always dealt with equations where y is the subject because we want to be able to use that function notation. Y equals f of x. Okay, we can't use function notation unless we have a function. Okay, and so I want to rearrange these. Now, to be clear that this isn't one function, this is actually 2 functions. So f of x equals the positive square root is a function, f of x equals the negative square root is a function. Together they're not a function, but for ease in terms of what I want to do, we're going to think about it that way. So the point is though is that we need to have y as the subject so we can call it f of x, so we can then think about how we apply our transformations. So I want to work through 2 examples here where we're going to see how we might apply these transformations we've just discussed to change the radius in the first example and then to change the centre in the second example. And from that we'll draw a conclusion about the more general equation for the circle. So by applying suitable transformations to the above equation, find the equation for a circle with its centre at 0, 0. So we're going to do no translations. We're going to leave it where it is. And a radius of 2. Okay, so radius of 2 means we're going to need to dilate by a factor of 2 from the x-axis and dilate by 2 from the y-axis. Okay, so that means that we need to find the equation is going to be y equals f of dilating by 2 from the x-axis will be 2 times f of x, and then dilating by 2 from the y-axis is going to be half x, okay? Or maybe we write that as x on 2. So remember, it's about the reciprocal of that number. So if we have half x in there, that's a dilation by the reciprocal of half, which is 2 from the y-axis. So let's do that for this function, okay? So that means we're going to have 2 times, so I'm going to have, it'll be plus or minus 2. If you've got plus or minus 1 times the square root, multiplying that by 2, plus or minus 2. Square root of 1 minus x on 2 all squared. Okay, so what I'm going to do now is I'm going to rearrange this back to the standard equation form. So we want to get a circle, equation of a circle. We want to get back to this kind of shape. So what I'm going to do here is I'm going to divide both sides of the equation by 2. So I'm going to have y over 2 equals positive or negative square root of 1 minus x on 2 squared. And then we're going to square both sides, which is going to give us y on 2 squared equals, we're squaring both sides, 1 minus x on 2 all squared. Alright, then I'm going to add the x on 2 all squared plus y on 2 all squared equals 1. Alright, let's expand these. So this is actually x squared on 4 plus y squared on 4 equals 1. And if we multiply everything in the equation by 4, we're going to get x squared plus y squared equals 4. And so this is a graph with its centre at 0, 0, so we haven't done any translating, and a radius of 2. So be careful about that. We've ended up with 4 here, and that's because we ended up doing 2 squared in the process. So actually, when we have a circle, if we have x squared plus y squared equals r squared, that means we get a radius of r. Okay, so it's going to be the square root of the number over here to give you the radius. So in this case, square root of 4 gives me 2. Okay, so now I'm not going to expect you to be able to do that yourself. I just want us together to work through that process to be able to get a sense of what does it look like in the equation of a circle when we change the radius. And the key to that is it's really just all about this number over here, changing the radius. And what I want to also be clear about is that that doesn't change any of what we've already understood about transformations. It's just slightly more complicated to apply the transformations to a circle. So even though it looks like a circle's behaving differently to everything else, I just want to illustrate here for you that it's not different. It's exactly the same. It's just because we write the equation for a circle in a different format to usual. Okay, example 2, by applying suitable transformations to the above equation, find the equation for a circle with its centre at 2, 3. Okay, so we want to translate to the right by 2 and up by 3. Radius of 1, we want to do no dilations. Okay, so if we want to go right by 2 and up by 3, that means we want to do that means that our equation is going to be y equals f of x minus 2 plus 3. So thinking about the fact that this is our function up here, f of x equals plus or minus square root of 1 minus x squared. Okay, so it's going to be plus or minus square root of, so remembering we're going to take the x minus 2 and we're going to replace the x's in the function with x minus 2. So it's going to be under the square root 1 minus x minus 2 all squared. Okay, so this is 1 minus x minus 2 all squared. And then we've got the plus 3 outside of the function, so separate from the square root. Okay, so again I want to focus on trying to rearrange this back to look more like the equation of a circle. So I'm going to take away 3 from both sides, first of all. And then I'm going to square both sides, which will get rid of the square root. And then finally I'm going to add that bracket of x minus 2 all squared onto the left-hand side. And so this is our equation after we've got it with the centre at 2, 3 and a radius of 1. Okay, so we've already talked about radius is to do with that. Square root of that gives me the radius. Now the centre at 2, 3 is to do with these numbers here. So minus 2 in here moves us to the right by 2. Okay, minus 3 in here moves us up by 3. And this is where the circle's a bit different. And again, it isn't different. It's plus 3 on the end here. But when you rearrange it into this format, it looks like it behaves a bit like the horizontal translation. So, and y minus 3 all squared will actually go up by 3. If it was y plus 3 all squared, that would go down by 3. Okay, so we just need to be a bit careful about how we interpret what's happening here. As I said though, it's not any different. It is still adding 3 onto the end of the function, but when we rearrange that function into this different format, this is what it's going to look like in the equation of a circle. So generally speaking, this is our equation for a circle with a centre at hk, okay? So to the right by h and up by k, x minus h all squared plus y minus k all squared, and the radius will be the square root of that number on the end, okay? Now, general equation, we can rearrange these to get our general equations for our semicircles, so top and bottom semicircles and left and right semicircles, but to be honest, I wouldn't worry about remembering these. Personally, if I had a semicircle equation, I'd rearrange it back to this form so I can correctly identify the centre and radius. I would just use this ugly form at the end here to decide which half of the semicircle is it, top, bottom, left or right. Okay, but we'll do some examples. I'll show you what I mean by that. Okay, so we want to sketch some graphs. Sketch the graph of y squared plus x squared plus y squared equals 9. So there's clearly no translations, okay, no x plus or y minus or whatever. But there's definitely a radius change. Okay, so the centre is clearly still at 0, 0. It hasn't moved. The radius is going to be the square root of 9. which is 3. We only worry about the positive square root of 9 because a radius is a length and it has to be positive. So we've got a circle with its centre at the origin and a radius of 3. So like any graph, the centre is a key point for these graphs, and then obviously x and y intercepts are important. And in this instance, the x and y intercepts are the nice extremities of the circle, so it helps me to draw the circle by marking those points. I find it quite hard to draw the circles accurately. I tend to draw them in 4 quadrants, as you've just seen, so mark your 4 points that show the extremities of the circle, and then just join them up. So that's 0, 3, this is negative 3, 0, and this is 0, negative 3. So no calculations needed to find those x and y intercepts if I think about what I'm doing. Okay, so there's my graph. Sketch the graph of x squared plus y squared equals 5. Okay, so again, we've got no translations. So the centre is still at 0, 0. The radius is clearly going to be the square root of 5. Okay, so root 5, root 4 is 2, root 9 is 3, so root 5 is just a bit more than 2. That doesn't really matter. Still just going to draw in a circle. Okay, origin, try and mark 4 points that are all equidistant away from that origin. Join them up with quarter circles. What really helps is, it's really easy to kind of get it looking a bit strange. You want to make sure that when you start out from here, you need to start out horizontally and you need to end up going vertically here. Okay, so horizontal to vertical to try and get your circle right. Okay, obviously that was a bit extreme. But yeah, you sort of want to, it kind of helps to get the shape a bit better if you think about that. Okay, so this is the point root 5, 0, this is 0, root 5, this is negative root 5, 0, and this is 0, negative root 5. Centre is at the origin, don't technically need to mark with coordinates, but doesn't hurt. Okay, so all axis intercepts and the centre marked. Alright, example 5, sorry. So here we've got, sketch the graph of x minus 1 all squared plus y minus 4 all squared equals 4. Okay, so this is going to the right by 1, and this is going up by 4. Okay, so the centre is at 1, 4, and the radius is the square root of 4, which is 2. Okay, so centre at 1, 4 with a radius of 2. Okay, so let's think about what's happening there. It's really important or really helpful when you're drawing a circle, you want to make sure you do work with the same scale on the x and y axes. If you don't, when you mark in all the correct points, you'll end up drawing a circle that will look like an oval because you've used a different scale on the x-axis compared to the y-axis. So this is the one case where it helps you hugely if you make sure that you draw the, you use a scale that's square. Okay. Okay, so 1, 4 is going to be my centre. Radius is 2. Okay, so I don't need to mark the coordinates of this point up here because it's not an axis intercept, but I'm definitely going to think about where it is. So the maximum point is going to be up there at 1, 6. The minimum point is going to be down here at 1, 2. Okay, going to the right by 2, that's going to be at 3, 4, and negative 1, 4. Okay, so you want to try and, sorry, it's a bit far over. You want to think about where those points are, even if you don't need to actually label their coordinates, because they're going to enable you to draw the circle. Now we can see that we're going to cross the y-axis here. Okay, as we go around here, we're going to cross the y-axis. So let's calculate those y-intercepts, but we're not going to cross the x-axis. So y-intercepts, so let x equal 0, so 0 minus 1 squared plus y minus 4 squared equals 4. So it's negative 1 all squared, which is 1, plus y minus 4 all squared equals 4. So taking away 1, y minus 4 all squared equals 3. Perfect example where I know half of you are going to be really tempted to expand those brackets, but it's completely unhelpful to do so. You're solving for y. There's only one instance of y in the equation. Just rearrange it until you get y on its own. So take the square root here, plus or minus root 3. And so y is 4 plus or minus root 3. Okay, so I'm going to mark the intercepts using those values. Root 3 is about 1.6, so it's going to be at about 5.6. 4 plus 1.6 is about 5.6, and sort of, 2.4-ish, just to give a sense. But again, you can really just draw in your circle and then then mark your points after that. Okay, so this is the point 0, 4 minus root 3, and this is the point 0, 4 plus root 3, and we've got our centre. So centre and at least 1 point on the circle is minimum information, okay? But you must make sure that all axis intercepts are marked. Okay, example 6. Sketch the graph of x squared plus y minus 3 squared equals 16. Okay, so no translation left or right, but up by 3, radius is root 16, which is 4. Okay, so we know the centre is going to be at 0, 3, and the radius is 4. Okay, so again, let's think about, so it's not gone left or right, so it's all going to be centered around the y-axis. So 1, 2, 3, 4. Oh, I forgot, I've got such a big radius. Let me make them smaller. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll do me. 1, 2, 3, 4. Oh, trying to think about it. Relatively similar scale on both axes. Okay, so centre is at 0, 3, radius is 4. So the maximum value is going to be at 0, 7. That's a y-intercept, so we'll mark that in. Centre at 0, 3, and the minimum value is at 0, negative 1. Okay, there's my radius of 4. We're then going to come out to the right by 4, out to the left by 4. They're not axis intercepts, so I don't need to mark the coordinates of those points, but I am going to mark those points. And then we're going to calculate my x-intercepts. Okay, we're going to cross the x-axis, so we let y equal 0, so, sorry, x squared plus 0 minus 3 squared equals 16. Negative 3 all squared is 9. So x squared is 7, so x is plus or minus root 7. Okay, so root 7 is somewhere between 2 and 3. So that is root 7, 0 and negative root 7, 0. So we've got at least 2 points on the circle, at least 1 point on the circle, sorry, plus the centre. In fact, we've got 4 points on the circle because we've got both 2 y-intercepts and 2 x-intercepts. Okay, so then we've got some semicircles. So as I said, I don't worry about the general form of the equation of a semicircle. I identify that I have a semicircle because it's the square root of something minus x squared, okay? I identify which part of, what's the shape, so y values are negative, so that means it's the bottom half of a semicircle, okay? And then other than that, I would rearrange this equation back to the standard circle form to be clear about what's happening. So that's how I tend to think about it, rather than remember all the different versions of equations for semicircles and circles, okay? So I would now focus on taking the square root of both sides, squaring both sides, so y squared is going to equal 36 minus x squared, and then adding x squared. Okay, so from here we can see that we have a centre at 0, 0, and a radius of 6. Okay, so it's this shape, but with a centre at 0, 0 and a radius of 6. Okay, so origin, okay, again, don't need a lot of scale, so I'm just going to make sure I've got points that are equidistant from the origin. Draw in my semicircle. If the radius is 6, we know where all these points are without actually calculating the radius. The centre is still an important feature of the semicircle as well. Okay. Sorry, without actually calculating the x and y intercepts, we can just use the radius to mark those points. Okay, again, this is quite complicated. I'm seeing that it's a semicircle. It's the square root of, no, that's my mistake, sorry. Can we correct that? That should be a y in there. Square root of a number minus y plus or minus a number all squared. So the first thing I'm seeing is I know it's a semicircle. X is positive, okay? So the shape is going to be the right-hand half of the circle, okay? Where the X values are positive. Then, sorry, that has to be Y. Then in order to work out what's happening with the radius and the center, I prefer to rearrange it back to be the standard kind of circle form. Once I've used the square root form to identify which half of the circle am I going to be drawing. Okay, so I'm going to take away 1. I'm going to square both sides. I'm going to add that y plus 2 all squared. So we're going to have x minus 1 all squared plus y plus 2 all squared equals 4. Okay, so I can see from this that the center is at 1, negative 2. Okay, right 1, down 2. Okay, remember the y's are also backwards. And the radius is 2. So square root of 4. And so we've got the right-hand circle with its center at 1, negative 2 and a radius of 2. Okay, so let's think about what we've got here. Okay, we want to keep the scale square. 1, 2, 3. 1, 2, 3, 4. Okay, so 1, negative 2, that's my center. Remember, we're only doing the circle out this way. Okay, so we want to go radius of 2, so 2 above there, we're going to be at 1, 0. And 2 below there, we're going to be at 1, negative 4. And 2 out to the right, we're going to be out here at 3, negative 2. So we don't need to solve anything to find the axis intercept. We've only got one axis intercept at 1, 0. With semicircles, though, we do have endpoints, and endpoints should always be marked as well. So any point where the graph stops randomly should be marked with coordinates. And it's an included point, so it should be a nice solid circle. Still mark the center, that's an important feature of the semicircle. Okay, so the work to do today is on a worksheet, graphs of circles and semicircles.